Hello, this is Terry Dennery of the MathWorks. Um, in response to a few people who have watched our series on Mechatronics with MATLAB and Simulink, and in particular our second video, we're going to dive a little bit deeper on this one into how you can import mechanical CAD assemblies into Simulink. So the basic idea is to get it into Simulink, and so this is the model that we've been working with in our series. And we hit run and we watch the video. All right, and so this is kind of a completed model with electric actuators and controls to make the robot move through a very precise trajectory. So let's just check our clock right down here in the lower corner of our screen. We're beginning at 1 o'clock and 1 minute at July 28th, 2016. All right, so let's see how fast we do this. All right, so basically I am going to take advantage of a tool called SimWise. It's a MathWorks partner, and you can learn about by checking out our website, and you'll see a lot of our partners are there. So anyway, so let's begin by opening up our geometry. All right, we're going to bring in Siemens NX geometry for this robot. Okay, so the import will take, I don't know, probably about 20 seconds. There's the full robot. I'm going to hit run and you'll see that it falls downward. Okay, now I want to get this in a vertical position, right? And I also want to work with this component right here, which will be essentially my anchored body, all right? And we could go into position. We could choose fixed, all right? And I hit run and that part's there. Okay, but I needed this whole thing to be rotated so that it's lined up with the z-axis, right? And so I go into properties. I see I can turn it according to a definition in radians, which actually I don't know radians well enough to really have good intuition on that. And so I'm going to go to units and change my units to SI degrees, all right? And now I'll go to RX, apply it, close, and I'll see that that component rotated, but nothing else did. So let's undo that, and let's try again. All right, and so this time, I want to really select basically the whole assembly. Right, and so for many reasons, it's good for me to kind of start working with this list. Right, and we're going to see essentially a hierarchy of sub-assemblies and all that kind of stuff that was really defined in Siemens NX, and it's defined in pretty much every CAD tool. Right, I'm going to do something called rigidly joined bodies. Right, and this is really kind of a trick I'm showing you right now. Right, and because this whole assembly is now connected, see I hit run, it doesn't fall. It means I can take this part now and I can rotate it 90 degrees and hit apply and the whole assembly's there. All right. Okay, what I'm going to do is now hit view all. Actually, you know what? Here's what I'm going to do. I'm going to type in H. That's my home view. And now when I do what I call view all, I'm going to get the view that's going to be my standard view I'm going to come back to. All right, I'm going to go and set that as my home view now. And so now it means I can mess this up in any way I want, whatever. And I can type in H and it puts me right back there. All right, so right now it's a rigidly joined assembly. We want this robot to be able to move, and so now we will undo what I did, which was rigidly joined bodies. All right, and so this brings us back to this position, which means that we only have that one fixed part. And so what we're going to do now is one by one, just kind of go through and put in the relevant joints that connect the assembly. All right, let's rotate it slightly. Let's hide this piece, and now let's define our first joint, which will be a motor. It's going to drive the vertical rotation of the entire robot. All right, and so it begins by placing a coordinate frame that essentially locates where that motor will take place. All right, so in its selected state, we see the square frame. Unselected, it's just a circle. So in its square state, I will select it, and the invisible part is one I want to connect to. And I go and I find it in this list because it cannot be selected from the viewing area right now. All right, and with those two components selected, I go create constraint. All right, now we'll get into this a little bit more, but basically we're going to form a joint between the fixed piece, which is called the base reference, and then this little bracket called the turntable base. Right, and so let's choose for that to be a Revolute Motor. Let's click create. Let's bring this turntable base back, and let's hit run and see how we did. All right, so we created a motor, and it's going to drive the rotation at 90 degrees per second. All right, so let's hit H and get back to this view. All right, and this piece called turntable base, I want you to notice it's part of an assembly called the turntable, blah blah blah, ID number and so forth. But let's go ahead, and what I'm going to do now is rigidly join all these bodies. All right, and so by doing that, I get that entire piece, moving as one, one component. All right, so let's go and do our next joint. All right, and actually, before we do that, I'm going to go into my motor, and I'm going to do something that I highly recommend, is really start, labeling these things with, names that really indicate what they are. Okay, and so I'm going to just call it turntable motor, and we'll hit apply, and we'll close. All right, and let's go zoom in right here. All right, and let's hide. All right, and what I'm about to do now is create my next motor. And you can see these blocks right here. I might even make this one like a more pronounced color. Let's make it black. Close. All right, and that's my motor. There's actually a motor right there as well. All right, and we can make that black too if we want. Maybe we'll do that later on. All right, so anyways, what I want to do now is I want to, again, locate where this motor is going to take place. And what I'm really doing is defining the axis of rotation. And particularly in this example, you're going to see two motors. They're redundantly powering this axis. It's this axis that actually requires the most torque, and that's why it's been designed this way. All right. And the key to kind of putting these frames in is you'll notice these blue circles when I'm doing it. Those are circular features that the tool's detected, and if I hover my mouse over any of these blue circles, I see an icon for the frame tool, the coordinate frame tool, that looks like that. If I move it over here, it's a regular image. If I move it there, it detects a surface, stuff like that. Okay. Anyways, let's go ahead and create our next one. All right, so with that selected, and let's see, where's my hidden part, which is going to be part of the bicep, and I see it right there. All right, so anyways, let's again create constraint. All right, and what you're kind of looking at here, is an automatic fill of the key, I'll call them key components or key features that are going to define what a joint is. Right, and so essentially a joint is made up of two chords. All right, and so we've selected one. That one that we selected is attached to this piece called servo horn. Okay, and so that automatically fills that part. The other thing we selected was the second part, the part that will be adjoined to it, and that will be, at that same location of our selected frame, it will it'll create another frame attached to it. All right, so just trying to give you a little bit of information about, how the whole process works. Bicep motor. All right, so we hit apply. All right, and let's bring our part back. Okay, all right, and we'll hit run. All right, and we'll see, everything not connected yet. It's going to continue to fall due to gravity. Let's hit home. It's kind of where we are. And so for that bicep, let's rigidly join all those bodies. Okay. All right, and we'll just keep on kind of applying the same process to move through most of the robot. Okay, so I'll hide this part of the bicep this time to get to that piece of our next, component, which is going to be called the forearm. All right, and so again, let's mark the constraint, or mark the joint. Okay, select our hidden part, right mouse click, create constraint. All right, show. All right, and these guys, which are all part of the upper arm, I guess we called it forearm, but the CAD guys called it this. Oops, let me make sure. Now there it is, forearm. Right? You can actually see there are quite a few parts that make up this assembly, but again, very rapidly we turn it into one. Right? So it is called the forearm. Right? And let's type in H, and let's just make sure we did all that right. So far so good. All right. Zoom in here. All right, and so this is part of an assembly called the wrist. All right, and I think I'll hide this part. Place my frame. Go get the hidden part, and we will create our next constraint, Revolute Motor. All right. And this one will be called, I believe, the wrist motor. All right, let's click on apply, close, hit H on my keyboard, gives me that view, hits run, and things look like they're working pretty well. I'm going to go back to this guy. Yeah, see, it's still got its default name, which is Constraint 123, which is fine. It's just not as memorable, all right? And so this one we're going to call the forearm motor. All right. All right, so things get a little bit interesting as we get into, the gripper and all that kind of stuff. But again, it's not too bad. This part, let's bring it back. Thought it looked a little funny. All right, and it's all part of an assembly called the hand. All right, and again, I'm going to use this feature visit. Actually, I don't know if I've introduced it yet, but hide all others. It's one of my favorites. All right, and so I just kind of look at that, and I can see that this already, I can see that this is a part that's going to move as if it's one body. And so I'm going to just do it right now. Let's go ahead and rigidly join all those bodies. Okay. All right. And again, it's about defining the axis. All right. And I think I'll do it this way. I'll find my circular feature down here at the bottom. I'll place that frame. Notice when it you place a frame. Yeah, and this is as good a time as any to talk about this. It's a kind of a useful thing to be aware of. All right, and when I place a frame, it always has a z-axis pointing out. And actually, if you look in its non-selected state, this idea of a frame, it kind of looks like a thumbtack. And if it's a thumbtack, the pointer of the thumbtack is going to be your z-axis, right? And it's a little bit tricky to explain why this is so important, but I am going to make reference to the idea that the most common method of defining orientation is what they call Euler XYZ or orientation definition. So it's an Euler angle thing. And so for those watching this who have some experience with Euler angles, they'll know that the z-axis is kind of the last one that you define, and it's for a number of reasons why this makes for the most convenient axis to define your rotations about. All right, so let's go create our joint, and let's see, this will be with the wrist, and so I think I will bring the wrist back. All right, and I'm going to go be kind of take a shortcut, just quickly go grab that frame, grab this part, and this constraint will be a motor as well. And let's bring everything back. Right mouse click, visibility, let's show all. Let's go back to our configuration right there, our visual. Okay. All right. And now I'm going to kind of correct a mistake I just made. All right. And that this really is not going to be a motor. You actually can see that there's no black motor lined up with it. There's actually a motor right there. Let's go to properties and make that black. Okay. And And then let's go fix the one that we just did. All right, and so instead of this being a motor, this is simply going to be a constraint. All right, it's going to be a passive hinge that we use the term Revolute joint for. All right, and that the motor actuation really occurs through some gears. All right, and so let's zoom in. All right, and let's clear out some stuff so we can see it a little bit better. And so I think I will get everything kind of in a compact display on my list of objects, right? And so what I'm interested in is the wrist, and I am interested in the drive gears. All right, so it's visibility, hide all others. Okay, and the drive gear is actually a very simple little subassembly. It's clear to me that these are going to move as one, and so I'm going to go ahead and rigidly join them right now. And here's the motor. All right, in a second we're going to have to define the gear, but for right now let's just kind of get this assembly working. All right, and I'll place a frame on this little bearing, that little gray piece right there. All right, now I can even see, in this list right here, connections, that my selected object, the coordinate frame, is selected to this guy. All right, and so I want to keep that frame selected, but I do want to hide that bearing. All right, and so let's hide that. Okay, and that gives me a little bit better view on what I'm connecting to. All right, and so I'm going to try to get a good view like that. Select that and select this. And really I could take any of the parts that the axis definition is really defined by the frame. And since all these parts move together as one, any of them would work. But let's try to kind of continue to put things together in a way that really does kind of make more sense to us. All right, and so click create, and so this I'm going to call my gear motor. All right, and we'll click apply. All right, and let's just bring everything back. So visibility show all. All right, and let's hit H on my keyboard to get that view again. All right, and so with that, this is kind of what it looks like right now. Now notice this little part right here is just kind of freely spinning, and that's because we haven't imposed the gear yet. All right, and so let's get back to this view. I think what might be useful for us right now is to hide the gripper, and so I'll go like that and hide every bit of that. Yeah, and I think what really makes sense, and let's zoom in on it, is if you really just take those two gear parts and now let's hide everything else. So visibility, hide all others, right? And so in creating the gear, I'm going to actually select the tool as opposed to bring up the constraint tool palette. All right, and so I will go get a spur gear. All right, and I will place a frame right there, and I will place a frame right there. All right, and so now I have see the little green circles. That's the indication I do have a gear constraint. All right, and if I open up the properties dialog on it, you'll see that it did its best to kind of try to identify the gear ratio implied by this. I'd say don't rely on this, but I'd say it still is pretty useful. And this really is a 1-to-1 gear ratio. I wish I could just type it in. I'll provide them feedback at SimWise to maybe put that in. But I can do the math. All right, and what I'm seeing here is essentially these two numbers right here will add up to the distance between the two frames. Right, and if I change one, you'll see the other one will change too, as well as the gear ratio. And so having done this one before, I'll just type it in, but 0.195 I believe is the answer, and you'll see as I click into the other frame, now see I missed, so maybe it's 9.5. Is that it? Yeah, and that gets me a 1-to-1 gear ratio, and that's what I want. Okay, and so let's bring everything back. You can just click on any one of these parts and go visibility show all. All right, and let's hit H. All right, and we'll hit run, and now you'll see that I made a mistake. So let's Let's go fix the mistake. Okay, so anyways, took me about 3 minutes. That mistake of mine took place at like 120. We're now at like 123. So I just kind of edited that out so you wouldn't have to endure it. But anyways, let's kind of hit run, and I will kind of share with you what my mistake was. You can see it's fixed right now, and it was really kind of a rookie mistake on my part, and it was that I forgot to rigidly join the wrist. Okay. All right. So let's keep on going. We're almost there. All right. And, basically everything's in place right now except for the gripper. All right. I hit run. We'll see that little gripper falls off like that. So let's just go work on the gripper. Okay. So again, let's just drag this and we can kind of see the parts that need to be attached. All right, and so basically these two grippers slide along this track right here. All right, and so we'll define a constraint type that we haven't done yet, but this is what we'd call a slot joint or maybe a prismatic joint. When we bring it over to Simulink, it actually is called a prismatic joint. All right, and so the basic idea this time is to define that directionality with the frame that we're going to allow it to slide. So I place it on this perpendicular surface. So again, the z-axis is aligned in the direction that it will move. All right, and with that selected, and again, this is a frame that is connected to a piece called the gripper left. You see that parent-child relationship between coordinate frame and body. Okay, so that selected, and this piece right here, we've defined the information through which we can put in a rigid joint on slot. Create. Okay, now what it means by rigid is that it cannot rotate, that the two parts cannot rotate relative to each other. What they're able to do is simply slide relative to each other. All right. And the icon kind of represents that. Where Revolute joints are cylinders and Revolute motors contain cylinders that will indicate that rotation axis, these rigid joints cannot do that, right? And that they can only slide, and you'll see the joint itself reveals the direction it can slide into. Okay, and if you ever really kind of puzzled by this, you can go into this tool called Constraint Navigator, and you can use this move tool, and you can just really kind of test the constraint. You can drag it here and let it go, and it puts it back. Okay, all right, and so let's do the same thing for, I can release the tool by just hitting escape. That's what I just did there. All right, and so let's put in a frame on this side. Okay, and we place that frame on that surface like that. All right. Again, that z-axis defines the direction we need, and I will right mouse click, create another rigid slot, and I kind of got that. At this point, we're getting real close to being done. All right. And what we need to do is really kind of set up this crank slider mechanism. All right. And so this is going to be driven by a motor. All right. And then through these linkages that it connects to, these grippers, it's able to, through rotation, make them slide. All right, and so the way I'm going to do this one is I'm going to activate this chord tool. All right, and I'm going to place a whole bunch of them on at one time. All right, and so let's put one right there. All right, I think these chords are a little bit too big for kind of the size of what we're doing right now, and so I'm going to just go back into settings, display settings. Instead of allowing these to be automatically sized, I'm going to make them, instead of 2/10 of a meter, let's make them, or 2 centimeters, I'm sorry, 2/100ths. Let's make them 5 millimeters, okay, in size. And so these frames are a little bit, better proportions for us now. And so let's go ahead and put frames right there, right there, right there, and then right there. All right, and we got frames now. We still don't have joints, but they are attached to those parts. And now let's just kind of finish this whole thing up. And so with that middle frame selected, I'll select this piece, which is rigidly joined to the motor, and we will create another Revolute motor. Create. All right, so we got a little rope motor icon in there now. Let's create the connections to these links. There it is, Revolute. Okay, and these last two I'm going to do a little bit different. Okay, and what I'm going to get at is kind of an issue when you have closed mechanical linkages. And the basic idea is that this crank is connected to this piece, that then connects to this link, connects to this piece, which then is connected to this piece again. Okay, and for various reasons, you want to be a little bit careful, and you generally like to impose as minimal a constraint as possible. All right, and so what I'm going to do is I'm going to select that. Let's move back here, and you'll see I'll select the little slider, the little gripper. And this time, the type of constraint I'm going to form is a spherical joint on a slot. All right, and so a spherical joint on a slot, the icon is a sphere, which means it can rotate about any of these axes. And you'll see if I can do this well, yes, that there's a little green line coming out this way. All right, now because of its connection to all these other parts, this gripper piece will not be able to come out along that axis, but it's important for the way that the calculation's done. Right, and again, if that's complicated at all, send me an email, and we'll go into a little bit more depth on why I'm doing it. But it's certainly a recommendation that I do have. And so to finish this, I will select this additional frame. I'll select that part, and we'll put another spherical joint on a slot. Create. Okay. And we're real close to being done. Let's hit H. Brings us back to our home view, and that's kind of where we are right now. All right, and we'll see the gripper is actually moving as that crank gets driven by that motor. All right, and here's kind of the last piece we're going to do. All right, and it's that in the design of this robot, and I think this was kind of an afterthought, but I think they realized they had to do it. I think they actually underpowered it, and it's this guy right here. The forearm axis is the one that's really kind of underpowered. And so what they did was they attached like a linear spring, and a little translational spring. And so again, I'm going to go get the tool to do this, and they essentially connect it from that point to that point right there. Okay, and you can see the icon right there, and we probably would want to go in and put the appropriate spring and damping and all that kind of stuff. It does automatically calculate for you from the current position what it would call I'll call it X0, the unstressed length of the spring. All right, but with that, we're about done. All right, and I'm going to just bring us back to this view right here. All right, and just kind of check and make sure I named all my motors and stuff like that. And so bicep, gear, forearm, wrist, turntable motor. What's that one? Oh, this guy. All right, let's see what's missing. The gripper motor. Okay, and we'll just call it gripper motor. All right, okay. And I'll call that my gear, and I will call the spring, and let's see, where's my spring? Let's hit run, just gonna see how it's all working. Oh, I really did mess up that spring. So the spring goes from this piece. to right there. Okay, and with that, it now appears in the list. I might add a, well, we'll just call it spring. All right, and so you're going to see we're at about 33. So I think we did a pretty good job, especially with the narration of showing that all this could be done in 30 minutes. So let's just bring it into Simulink now. I think I'll save it. File, save as, and I will call it robot video. Save. All right, and to bring it over, and this is a new addition that was made by these guys at SimWise. Instead of kind of bringing it over via a MATLAB script that I had written, it's all done through this interface. And so I go to File, Export, Simscape Multibody, and we'll just kind of watch it go over now. All right, so most of the work is going on in MATLAB. You'll see it brought up, this MATLAB command window. And in a second, in MATLAB, we will see it opens up a new Simulink model. And probably over the next 15 seconds or so, it's going to start placing all the blocks in and giving them all the right mass properties. And here we are. All right, and you'll see that for every one of our motors, we have an input-output structure that's been set up, and it's all this kind of stuff that we really get used to great advantage and described quite well in the video series Mechatronics Systems with MATLAB and Simulink. So let's go ahead and hit the run button, and we'll see where we're at. Okay, and what was automatically created for us, is all right here. And we might do a few things to just kind of clean it up and make it look a little bit better, but not bad and very, very helpful tool. Okay. Okay, so we made a conscious choice with this video to allow it to be a little bit more instructional than the videos we've been doing up to now. And what I mean by that is that we tried to capture every mouse click so that you could reproduce what we did here. All right, and so anyways, I'm going to list here the products that we used to do this, which included MATLAB Simulink, of course, but also Simscape Multibody is the component that MathWorks provides to allow you to build mechanical models inside Simulink. We saw great advantage was had by using this tool SimWise, which has a wonderful graphical user interface to build these mechanical models as well. So anyways, thank you very much for watching this video. Again, I'd love to hear from you. I've listed my email address this time. Again, feel free to look me up on LinkedIn or Twitter or whatever, and let's have a great conversation. If you liked the video, please give us the thumbs up. Again, we appreciate that very much. So anyways, this is Terry. Thank you. Bye.